Hi, everyone. Welcome to our session today. My name is Moria, and I'm based in Israel. I'm part of the Reactor team here. Today's session is the first one in our joint series together with the Reactor in Sydney. So it's going to we are aiming to bring you speakers from both Sydney and Tel Aviv, and hopefully trying to bring together their communities as well. Just before we start, a few housekeeping. As you can see now on the screen, you have the checking slide. So please feel free to check into the event for today. You need to just add the event ID. I also shared the link with you on the chat for this session. The session is going to be recorded and it's going to be available for you on the Reactor YouTube channel, which I will also share the link for that shortly. We encourage you to ask questions, so feel free to ask any questions you have in the chat box, and the speaker will take the time, I guess, during or probably at the end of the session to answer your questions. And that's it. I will also be helping to moderate the session, so I will be available, so feel free to connect anytime. So I'm going to hand it over now to Dror Cohen, who is going to deliver our session today. So as I mentioned, this is a first series together with the Reactor in Sydney. The series is on IoT, and the first session will be on challenges in the security of things. So hopefully you will enjoy today's session, and we will see you in the next two events of this series. Thank you, and over to you, Dror.
Hi everyone. As Moria said, I'm Dror. I'm based in Israel. I'm an principal engineering manager at Microsoft. I've been working for Microsoft for the last 14 years, and in the last 3 years, I've been an engineering manager in the Azure Defender for IoT product, and our goal is to help companies and individuals protect their IoT devices from malicious things. So today I'm going to talk a little bit about the challenges of IoT security, and I must say that it's an intriguing domain that all of the IoT domain is evolving right now in a crazy way, and the security become a really major deal in this area. So we're gonna talk about that. But before I go there, I just wanna one more sentence about myself is that I'm also a pastry chef. I like baking and sweets and all this stuff. So just wanted to share with you my passion for sweets. And let's go there. What is IoT? So I know this is a IoT series, and probably most of you know what is IoT in general, but I wanted to tell you a little bit about what is IoT from my perspective, or from my group and product perspective. How do I consider IoT? And I really like this Wikipedia definition of IoT, that Internet of Things is basically a network of physical devices. It could be vehicles, it could be home appliances, it could be other stuff. And the focus here is on connectivity and the data they exchange between them and between the network, and they result in efficiency improvements. Why this is important? Because IoT basically really started a long time ago. We think about it as something new, but it's actually not new. It started in around 1982, where the first internet-connected appliance was actually a Coca-Cola vending machine, which is really cool from my perspective. We jump a few years forward, and there is this guy, Kevin Ashton. He is the one responsible for the term Internet for Things. That's the term he originally used, which transformed over time to Internet of Things when he invented the RFID. And this was basically the beginning of the real deal. Then the Chinese government started a 5-year IoT strategy in 2010, which actually led to an IoT boom, you can say, where the ratio, and this is the way to measure how many devices are out there in the world, the ratio between things and people. The ratio between devices and people in the world grows from 0.08 devices to person to 1.84, so almost 2 devices per person in the world today. This number is much higher. We'll talk about it in a second. Another interesting event on this timeline is when Google buys Nest, a startup that deals with an IoT thermostat that you can set up in your home for $3.2 billion, which is a huge amount. Basically, I think the largest IoT related acquisition by that time, at least. And then in 2016, security becomes a major concern for IoT, and this is what the rest of the talk is going to focus about. But before we go there, just a few more things about IoT in general. So we perceive all of these things like IoT. Ordinary people, if they heard the term Internet of Things, they usually, when you ask them what is Internet of Things, they will usually think about this stuff, right? Some stuff that they have at home, an Alexa, a Google Home device, a watch they wear, other wearables, other devices they have at home. But when we look at IoT as Microsoft, and I think the industry in general, we actually see it as a far more diverse thing. It could be manufacturing, machines that are inside factories that build stuff. It could be in retail, the customer experience when it goes to a shop or store. It could be in healthcare. There are lots of healthcare devices today that are actually IoT devices, and we'll see one example later in the slides. It could be transportation, vehicles, airplanes, trains, traffic light systems, and so on. It could be in energy. Energy is a huge domain in IoT. There are lots of energy companies are starting to connect the devices. Think about this windmill, for example, here. It's in a remote location, and then the company need to have some indication of what's going on with it. So they connect it. It's become a connected device that they control remotely, and the technician will only need to come to this on site when something bad happens. And it could be agriculture. Another really a good example that is in good development. In recent years, a lot of agriculture companies develop IoT solutions for watering systems and other stuff that measure environmental impact. And one of my favorites is smart cities. I mentioned the traffic lights, but it's a lot more. Lots of cities today, they have cameras spread across the cities. They have other smart things deployed over the city that enables the city to control what's going on and see what's going on and so on. So this is the boom I talked about. So if we look at the number of devices, connected devices, we have around 92 here. We have 1 million connected PCs. But if you move forward, you'll see that in 2020, we are now on around 50 billion devices in the world. And you can see at the bottom of the slide, it says that the ratio between things to people is now around 8. So 8 devices out there in the world for every person living on the face of the earth, which is, from my perspective, it's an amazing fact to know. So now we get to security. Why IoT security became a major deal right in these past few years. You can see the increase in the amount of IoT related attacks in the past couple of years, from June 2018 to May 2020. You can see the jump here, right? So many IoT devices are now the target for malicious attacks, cyber attacks. Hackers are looking for these devices, and they're trying to do things with them, and we'll talk about what they're doing with them in a minute. But before I go to the attacks, I wanted to pause for another minute to talk about this slide, which shows the amount of money that companies spend worldwide on security related to IoT, and you can see the increase as well. So it's in millions of dollars. And while in 2016, for example, companies would spend around $900 million on IoT security, in 2021, we already passed the $3 billion. So the industry understands that, and the industry knows that this is a major deal, and they spend a lot of money on securing their devices. So there is a shift in the mindset of the industry. Tell you that it's enough? No, it's not enough. Most of the devices out there are still compromised, and this is basically one of the main reasons I'm talking to you today. So a couple of years ago, Microsoft came up with this declaration that it's going to spend $5 billion in IoT. And when they say in IoT, it also includes in IoT security. It's part of the deal. Microsoft has spent a lot of effort in the past few years to develop a platform in Azure that will enable customers to connect their devices to the cloud, to the Azure cloud. And as part of that, we also bring IoT security as part of the package. So if they connect the devices to the cloud, they also get better security for the devices. So let's go to see some examples of attacks that happened over the last few years. So this thing you see here in this photo, this weird thing you see, it's a centrifuge. It's a hot topic, I think. Centrifuge usually it sits in nuclear facilities. You see there are many of them over here, and there was around 2016 there was a virus called Stuxnet that basically attacks the controllers. Each of these centrifuges has a controller attached to it that controls its operation. It's a virus that attacks this controller and basically could be used to ruin the centrifuge, to make it work too fast or in a way that will actually ruin it. And this device actually costs a lot of money. So it's a financial loss to the organization that is using this, but also could be used, of course, for political impacts. This is the controller, and the virus actually attacked this controller. On the right side, what we see is, I mentioned medical devices. So this is a pacemaker, a heart pacemaker that is actually a connected device. It has the ability to control it remotely, and hackers found a way to hack these devices and make them do bad things to people who have them installed on their bodies. This is a fearful example of something that really bad could happen using attacks on connected devices. And this third example here, we have this Jeep car that hackers found a way to get into through the multimedia system on the car, to get into the brake system, actually affect the brake system, make it the car stop, or disable the brake system, which is another example of something really terrible that could happen if hackers would start doing bad things to our IoT devices. And the last example, I think perhaps the most known example is, of course, the camera. Security cameras or monitoring cameras like this are installed in millions or billions all over the world, in homes, in facilities, in many places. And this is one of the most attacked IoT devices. Actually, it's so popular to attack these devices that today there is a search engine that enables you to search across the world for cameras that are open, and you can see what these cameras are recording at that point in time. And this, if you're interested, this search engine is called Shodan. And just a couple examples that I found. You can see a baby monitored here, someone's kitchen over here, a class with kids somewhere in the world. Someone is working in his office, right? So it's really, really open. And it's so if you have a camera installed somewhere at home, at your work, anywhere, I'll double check that it's safe. Okay, I'll move on to the next example. So what I have here, I hope you'll be able to see the video. What we have here is another example where the hackers found a way to hack into a smart lamp. It's a Samsung smart lamp that you can control over the Wi-Fi to turn on the light, turn off the light, change the color, stuff like that. And what they did here is they used this drone to infect the lamps in this building with the virus that they created that makes them send out this code that is at the bottom of the video in Morse. It's a Morse code. You can see fairly easy. The drone just approached the building, remotely infected these lamps and make them go crazy. So now we get to 2016, and why 2016 is a turning point for IoT security. So in October 21st, 2016 at 2:30 p.m., DNS, which is one of the biggest DNS servers in the world, had 3 major consecutive DDoS attacks, denial of service, and this denial of service originated from tens of millions of IoT devices. So tens of millions of IoT devices were hacked by someone, and all orchestrated to just go and ask the DNS for DNS queries together at the same time. And this actually made the DNS servers go down. It's a big deal. So DNS serves over 70 major websites around the world. And this attack is called Mirai botnet. And we'll talk about botnets in a second, but that's to see who was affected by that attack. You can see Airbnb, PayPal, Amazon, Netflix, BBC, all of these, and many others were actually affected by this attack on the DNS. So this is the first time that an orchestrated attack happened in the world using IoT devices as the source of the attack. So not only they hacked the devices themselves and all the examples that we've seen before, that it could hack our cars or the cameras and so on. Now they can use these devices to attack something else, which is a big deal. This is an example of all the areas that were affected, that were down, were not being able to connect to the internet at the time of the attack on Dean on that day. And this guy here is the one that admitted to have written this code, this virus called Mirai. And this also had some further consequences where, for example, this is one of the example where a Chinese company had to recall over 4 million devices, connected cameras that participated in that attack on DIN. So, of course, they had to recall the devices because there was no way to fix the devices and stop them from attacking further things. And this I call rise of the botnet. So botnet, what is a botnet? A botnet is basically just like in the example we've seen right now, is an orchestrated network of IoT devices that are working together to do malicious things. And this since this attack in 2016, this has become really, really popular. So we can see here an example, a few articles. So Gartner said that by 2020, more than 25% of identified enterprise attack will involve IoT. And when they mean will involve IoT, they mostly mean this sort of botnet attacks. Another example over here, so DDoS botnets are being sold online for $5. So you can actually go somewhere and buy. Here, this example is on Fiverr. I don't believe it's in Fiverr anymore, but you can go somewhere online and purchase your own or lease your own DDoS botnet for the small amount of $5 and use it to do something bad to someone else. Here's another example where some organizations started to get these threats, let's say, or protection deals that say, okay, if you want to keep your site operational, you start paying us this sum of money. If you pay us, we'll protect you from botnet attacks. But if you don't pay us, then we might attack you. And they actually give you bonuses here, right? The 30% discount if you request a DDoS attack on one of your competitors. Excellent. So since then, the Mirai botnet in 2016, actually a lot of other botnets have risen. So you can see in 2017, another botnet called Satori was discovered. In 2017 and 18, Masuta botnet was actually attacking home routers as well, not just cameras, and you can, and so on. I'm not gonna go through all of them, but there are Wicked Mirai, GenX, OMG, and there are many others today. And you can see, I can buy for $20. I can buy my own DDoS attack on someone. And now an interesting story, somewhat related to all of this. There is this guy. It's not really a picture of him, but this guy in the world that's called himself the Doctor, and he, or should we call him the Batman? He decided to do the internet, give the internet a chemotherapy, and basically go out there, hack devices that's in the world that are hackable, and basically break them. He called this the Breaker bot. It's a bot that actually tries to break devices, make them stop working completely if they are hackable, and thus preventing them from being used by someone else to do malicious things. So they're actually trying to do a favor to humanity by destroying all the hackable devices in the world. He called this permanent denial of service, or PDoS, if you want. So it's basically taking out the devices permanently from doing anything. Another example of how IoT devices attacks could be used is for cryptocurrency mining. So hackers are sometimes hacking IoT devices and use them to make money by using them for crypto mining. And there is this famous example that went out a couple of years ago of a complaint that some allegations that North Korea was using this hacking way and mining cryptocurrency as a way to increase the income for the country. I'm not sure if this story is true or not, but it was all over the news by then. And this one is my favorite example. Here we can see the example of an aquarium that was installed, a fish tank that was installed in some lobby of a famous casino, and hackers would this fish tank had a thermometer installed in it that was able to control remotely, and hackers managed to hack this thermometer, and through that thermometer actually get access to the casino network, and they moved inside the casino network and got to the casino's customer database, which contained a lot of personal information of the casino customers. And this is interesting. In cyber security, we call this lateral movement. A lateral movement is a movement that the hacker is doing inside the network. He finds an access point, a way into the network of his destination, and then he started moving in through the network. So in these cases, the fish tank is not interesting for itself. We're not gonna use it to do DDoS attacks on someone else. We're not going to use it to do cryptocurrency. We're not going to do it to harm the fish tank itself or do anything bad with it. But we use it as an entry point into the network to find on the network other more interesting targets, like in this case the database. And this is something very common. So it happens a lot. And people and organizations are not aware that they might put a network camera installed in their organization or in their home, in their office, and not make sure that it's fully secure. And then hackers could use this camera to access the network, the home network or the office network, and do lateral movements within the network, and then get to the PC or get to a server, and then use it to do ransomware attack or stuff like that. So it's a very common practice. You should think about all the entry points you have to your network, and a good practice many cybersecurity people use at home, for example, if you're interested in what you could do about this, is to separate the two networks. Put all of your IoT devices on a separate network from all the things that you care about, like your PCs and laptops and phones and so on. Okay, another example, I think my last one from it's very, very recent. It's actually something that was discovered by our research group, and it has a lot of potential to make some damage in the world, and thus we published a recommendation for owners of IoT devices to fix their devices soon. So what we discovered is a leak, a hole in a memory allocation function that is a common library used in many IoT devices as part of their OS or firmwares. And so all of these devices, they should be upgraded to a more up-to-date firmware and to close this hole in the malloc function. And if this is not closed, then many of these devices are basically compromised today. So this affects millions of devices in the world, and we published in recent April all across the news a recommendation to fix all of these devices ASAP. So this is an interesting example, and these are always stuff like this always come up, so need to always keep up with what's going on. To kind of summarize all of the example I gave so far, I can show you here what are the most common attacks on IoT devices, how hackers are actually getting to into IoT devices. So in this orange here, you see attacks similar to the ones I talked about right now. It could be a leak in the malloc function. It could be an SQL injection. It could be any other vulnerability or exploit that is on the device, on the firmware, on the software, on the application. I think that we need to update the firmware version and the OS and all this stuff to get the device always protected. The green parts is basically malwares. They find a way to get into the device, and then they use it as a botnet, or they find some backdoor. They lock up the device and ask for ransom, and so on. And the blue part is actually where a user is actually to blame for the attack, where the password was too weak. You can see 30%. That's a lot of the attacks were due to weak passwords, or phishing attacks, or cryptojacking attacks. And this leads me to the next slide, where we actually try to summarize. So what's the challenges facing us when we try to protect our IoT devices? This is true both for customers or people that have devices and they need to think about security, but also to us as a company, as who tries to develop a solution that we can sell our customers and tell them, okay, use this Defender for IoT product to protect your devices. So what are the challenges that we as developers are facing? So they are divided to three. One of them is the scale. We talked about that a lot at the beginning of the talk. So millions and billions of devices out there that all need to be protected, and it's keep on growing and growing exponentially. So this is definitely a major challenge. The second one is the diversity. So there are lots of devices, and they all use different things. So it could be different OS, it could be different firmware. Some of them are Android based, some have Linux, some have Windows, some have RTOS, which is a real-time OS. Some have their own proprietary solution, and you need to find a way to protect them all, which is not easy. And the last one is legacy. So basically, like in the camera example from earlier, the Chinese company that had to recall 4 million devices. Some of the devices that just could not be updated or fixed, and they are out there in the world connected, and you need to find a way to either protect them or replace them. And you can imagine if a factory, for example, a big factory, car factory, for example, has machines that manufacture the cars connected to the internet there, and they found vulnerability there, and they cannot update the software of these machines. So they would not go and replace all of these machines. These machines cost millions and millions of dollars. They would not just go and say, okay, we'll take this machine out, we'll stop the production and replace it with something else. They need some other solution. So a couple of security takeaways for you, and then I'm gonna talk really quick about what we can do to face the challenges that I mentioned in the previous slide. So devices must have the ability to update their software. This should always be the practice, right? If you are a developer and working on in creating your own new device, you should always keep in mind that you should be able to update its software, its firmware, its passwords, everything should be updatable, preferably remotely. If not possible remotely, then locally, but preferably remotely. You should definitely change the default username and password on all of your devices. You should have best practices to have unique passwords per device and not repeating passwords across all devices in the fleet. Secure and encrypted connectivity, of course, this is common practice for anything connected to the internet today. Should be also applied to devices. It's not different. Strict configuration. So basically, turn off anything you don't need on the device. If you don't need the Bluetooth, You don't use it, close it. If you don't need Wi-Fi, close it. If you don't need it to open to all the internet, use firewall to close, restrict the traffic only to the network that you actually need access to. Of course, patch to the latest updates. These all seem very, very common and simple, but people are not doing that. And devices, many devices out there are actually susceptible to attacks today. And so to my last slide, I want to talk about how we can face these challenges. How companies like Microsoft and Amazon and many other companies out there trying to solve the IoT security problem will try to solve and face these challenges that I mentioned. So basically, there are three approaches possible. One is to use an agent-based solution. This means I'm installing an agent on all of my organization devices. And this agent, since it's on the device itself, it can proactively protect me. It can monitor the device. It can see if a device is in a malicious state. It can disconnect it from the network and so on. So this is one approach. But the problem with that approach is the challenges that I mentioned before of the diversity and the legacy. So diversity is an impact here because if I implement an agent like this, I have to implement many flavors of the agent, a version for Windows and a version for Linux and a version for RTOS and so on. And the legacy is also a problem because if I cannot update my device, if we get back to the car factory example, if I cannot update my machine, then I can also probably I cannot install an agent on it, so it's still compromised. So this not necessarily solve the problem, but this is one way to go. The other way to go is to go on agentless solution. So here we don't need to install anything on the device. We just use the network. We sit on the network. We can connect to routers, switches, or other elements in the customer network. Look at the traffic that's going on, and through the traffic, try to understand which devices are out there, which devices are compromised, and so on. So this is a better approach from the diversity and legacy aspects. But on the other way around, when you go like this agentless, then you still have to face the diversity of the protocols. So each device is actually communicating in a different protocol depending on the manufacturer. If it's a Siemens device, for example, they have their own set of protocols that you have to identify, and if it's a Rockwell device, you need to identify a different set of protocols and so on. So it's also a big challenge here as well. And not everything you can see on the network. Some things you can only see from within the device. So you miss some of the stuff that the first solution can propose. And the last approach would be to actually go to a hybrid solution where you have both agents installed on the device, where you can install an agent and monitor through the network the rest of the devices that you cannot install an agent on. And so just to summarize how this looks from our perspective, we as Microsoft has been developing in the past few years an agent-based solution that, as I said, part of the Azure IoT motion that Microsoft started a couple of years ago. We acquired CyberX startup that they brought into Microsoft the ability to use a network-based solution. And today we have Defender for IoT, which actually my group, which actually uses both of these technologies and created a hybrid solution that try to protect everyone. So this is our vision. That's it for me. Thank you for listening. And if you have any questions, I'd be happy to answer. Okay. I guess we don't have any questions. So thank you, everyone. And thank you for listening. And I'll see you next time.
Thank you so much, Dro. Thank you. It was a great session. I enjoyed it a lot. I hope you enjoyed it too. And yeah, I don't see that we have any questions, so we will wrap up today's sessions. And hope to see you at the next event in the series next week at the same time. Thank you, everyone. Thank you, Dro, and
Thank you.
bye
Bye bye.
bye. Bye bye.